So for a Kanban system, I'm going to use my AMS 490 project that I did. I had to design, it was a team effort, but I designed the whole new plant by myself. Nobody helped me with it. So it was very challenging. So when the presentation come around, we ran out of time on the presentation, so I never really got to show my work to anybody, and it took me hours just to complete it. So, and there's some Kanban principles in the plant when I designed it. So here's a CAD drawing of the plant. It consisted of 2 cells. Each cell had 6 CNC mills, 2 lathes, and 1 router. We had to make a plug that consisted of a base plate, an insulator plate, and then the plug itself. Well, for my visual tools that I used on this plant, I used a PLC. The PLC operated with, proximity switches and things like that. So looking at this is an HMI right here. Here's some indicator lights that I designed, and each of them has labels, which you can't read. It's a picture. I don't have access to the CAD program right now, but each one of these are visual symbols that would show you, like, for instance, this drop box right here is for the insulator plate. This one's for the plug, and this tray is for the base plate. So this robot comes down this line, and it senses that there's a box in here, like by a proximity switch. Well, if there's no tray in here to pick up the raw parts that have been milled, then this light comes on telling the workers, hey, they need to get this tray here so the robot can pick it up, because the robot's waiting on a signal from the proximity switch to do it. And these are light curtains, so it promotes a safe work environment because they can't get in there when the robot's running. So I also had it to where the insulator plate had a proximity switch down at the bottom. So when the parts ran out, the next light would come on, and it's got a label for it that there's no insulator plate, so the robot's not going to run because it doesn't have anything to run. Same with the plug, which is right here. It has a proximity switch at the bottom that will fault out if it doesn't do it. Here's a good better picture of it. The proximity switch would be down here, and the proximity switch would be right here on this one. So, and then the proximity switch on this one would be inside this box. Well, so to promote that, I would also have, to add a visual signal, I would also have this HMI. Every time that proximity switch didn't sense anything, I would have this HMI digitally display a warning across the whole screen to make it presentable. And I would also have this turned to where the employees back at the manual mill stations could see it, so they know that they need to hurry up and get parts to the robotic cell. Another thing I would add to this, if I had time and would want to do it, is when everything was made by the robots, here's where the drop plates are. So the robots drop, this is a conveyor belt, so this robot right here drops the base plate down on here, and it rolls until it gets to right here and drops in. Each one of these have three things. Well, a worker would assemble this and put it into a box, the finished product. Well, to promote quality of a product that you're not missing anything, I would have had a weighing station hooked up to the PLC as well, to where if you you put the finished product box, the base plate, the insulator plate, and the plug all in the box, and it's taped up, I would have a weighing station right there where the worker is, so he could set that on there before he set it on to the conveyor to take it down to where the robot puts it on the pallet. That weighing station, I would have an alarm, either a green and red light on the weighing station, to show that if it's missing a part and it's not the right weight, then he will know that product is missing something and it needs to be reopened up and fixed, so the customer you can ensure that the customer has the proper product and there's no quality issues whatsoever. The HMI right there would also, I'd have it displaying on the screen how many parts were produced that day, how many parts produced towards the overall goal of 100,000 parts.